In this lesson, we're going to discuss XML injection attacks. Now, XML stands for the Extensible Markup Language, and it's used by web applications for authentication, authorization, and other types of data exchange. According to the exam objectives, XML is listed under the injection attacks section, but technically, an XML injection isn't really entirely accurate. Really, what we should be talking about is XML vulnerabilities or XML exploitation, because really, the vulnerability is being exploited is the way XML is being parsed by the application. But for the purposes of the exam, if you see the term XML vulnerability, XML exploitation, or XML injection, they are referring to the same thing. Now, XML data must be submitted from a client to a server or from one server to another server. To protect the XML data in transit, we want to make sure we're sending it inside of an encrypted tunnel, something like a TLS tunnel. To protect your servers when it receives the XML data, you should always conduct input validation and input sanitization of the data received. This will help protect the server from any kind of XML exploitation or injection attack. If you submit XML data without encryption or without input validation, it is going to be vulnerable to spoofing, request forgery, and injection of arbitrary code. When you look at XML data, it's going to appear as a human-readable format with a series of tagged fields. For example, here's a short XML file that I created containing a practice exam question. The first line defines this text as an XML file and specifies what version of XML and type of encoding I want to use. The second line defines the type of data that I'm going to be using in this XML file. In this case, I'm defining the information contained as a question for a web application quiz program that I'm writing. Next, you're going to see there are 4 more fields inside this question type. The first field is included in the ID field, and you're going to see it contain the identifier for the sample question. Next, I have a title field, and I titled this question as, "Is this an XML vulnerability?" Next, I have the choice 1 and choice 2 fields. And now the great thing you're going to see about XML is that it can be configured with whatever fields you want based on your application that you're building. In this case, I'm showing you how I would define questions for this quiz application. Finally, you see the ending of /question and /XML tags to close out this data, just like you'd close out an HTML tag inside of a website's code. Now, if you see something like this on test day, you should immediately identify it as XML data. In this example, there is nothing malicious or suspicious here. It's just regular XML data being used to contain information and send it to or from another application. Now, let's talk about some exploits that you'll see used with XML. First, we have an XML bomb, also known as the billion laughs attack. Now, an XML bomb takes XML and then encodes it and uses that encoding entities to expand them to exponential sizes, which will consume memory on the host and potentially crash it. The reason this is called a billion laughs attack is that XML entries referenced in the file are written as LOL1 through LOL9, and each of these references the line before it as well. So if we start it from the bottom, we start seeing LOL9, and you can see there are 10 LOL8s inside of that. And then, as we go to LOL8, we can see there are 10 LOL7s, and this pattern continues all the way up. This essentially creates a billion LOLs because of the factorial nature of the entity references. This simple code can consume up to 3 gigabytes of memory due to the repetitive references being used. Now, if an attacker can get your server to parse this XML file, it can start consuming all of these resources on your web server. And this is why we call it an XML bomb, because it acts like a bomb or a denial of service attack, consuming up your resources. The second type of exploit we have is known as an XXE attack, or XML external entity attack. Now, this is a type of attack that attempts to embed a request for a local resource. That sounds an awful lot like a local file inclusion, doesn't it? Well, it is. Here's an example of an XML external entity attack. Again, notice we have an XML version and encoding in the first line. Next, we have the document type listed as foo, which is just code speak for some kind of a junk variable. Then we're going to have the element foo, any, and we have the entity XXE system, and then the file //etsy/shadow. And then we end this out with some kind of data type in XML, in this case, calling it foo. Now, most of this doesn't look too bad or malicious, but that fourth line that contains /etsy/shadow is inside of this XML entity trying to read the contents of the shadow file of the Linux machine. This would contain the password hashes for the system account, and we wouldn't want an attacker to get that. So, to prevent XML vulnerabilities from being exploited like these, remember, you always need to have proper input validation. Input validation, input validation, input validation. I keep mentioning it in a lot of our different web applications and exploits because it's really important here. Anytime you get input from a user or a client, whether it's a URL being inputted, a file being inputted, a field being entered on a website, or some XML data being sent, we can prevent a lot of security issues if we just conduct input validation. For the exam, if you see something with XML written in it that is clearly XML, guess what? That's going to be an XML vulnerability that's being exploited in that question. They might call this an XML vulnerability, an XML exploitation, or an XML injection. Whatever term they use, it's normally XML that's being exploited when you see XML formatted data inside of the question. Now, the only really tricky part with these questions is that XML code can often look a lot like HTML code or JavaScript. To tell the difference, remember that HTML or JavaScript uses defined keywords for each of those bracketed entries. But with XML, you can make those say whatever you want depending on how you configure your XML. So for the exam, I want you to stop and take a moment and look over any code they give you and first determine, is it HTML, JavaScript, or XML? If you see something like a font or an image or href in the tag, it's likely HTML. If you see something like question, ID, type, or element, or entity, those are XML. If you can make the determination between these, you should be able to have no problems answering questions involving XML vulnerabilities, exploitation, or injections on the exam.